Hi, Algebra 2. We are going to go over the second half of the Chapter 5 closure. All right, so starting with 5-132, it's asking us to graph the system of inequalities. So we have y equals x squared, and then we have y is bigger than or equal to x squared, and y is bigger than or equal to x minus 4, that quantity squared plus 2, right? When you solve a system, you have to make sure you're including that shading. So first for this graph of y equals x squared, remember we start by graphing the boundary equation. And these both have the equal to on the inequalities. That means they're going to be solid graphs. Remember, if it's just the greater than or less than, it would be dashed. Okay, so for y equals x squared, just our parent function for a parabola. Again, if you aren't sure what that looks like, go ahead and just make a quick table. We did a table for this a little bit earlier, so I'm just going to do that quickly, and I'm going to plot those points. I might go one more. I might do the 3 and the 9 also, just to really have an accurate graph. Okay, so there is my first parabola, and I'm going to try to, here we go, draw my curve. Okay. Now, got a little wonky there on the side. This is the same function, right? It's a parabola, but that -4 has moved my parabola to the right 4, and this +2 has moved it up 2. So really, I could kind of take the same idea of this table, and I could take these points I have graphed and move each of them to the right 4 and up 2. So there's my new vertex is at to the right 4 up 2, and I could just take each of these points and go to the right 4 and go up 2. Do that with each of those points. You could also make a table for this if you wanted to. If I were making a table, I would kind of put that vertex, that HK shift in the middle, and then pick a couple of points, X values above and below it. Okay, but I'm not going to. I'm going to just take each of these points, and I'm going to go to the right 4, and I'm going to go up 2, and then I'm going to get my graph. So there-ish. And then here is this parabola. I haven't done my shading yet, so we need to do that. Okay, so let's start with this one. Okay, now remember what we would do is we would test a point, and it has to be a point not on the boundary graph. So I like 0, 0 usually, but for this one, I would not pick 0, 0 because that's one of my points. I might test the point, let's say 0, 1, right? So in my inequality, I'm going to test the point 0, 1. So in this, y is greater than or equal to x squared. I'm going to put 0 in for x. I'm going to put 1 in for y. And is that true? Is 1 greater than or equal to 0? It is. So I want to shade for my pink one, everything that includes this point, right? So everything kind of inside this, my pink parabola, as best I can, right? All of this. Okay, now I'm going to test a point in my other parabola. Now I can pick 0, 0 because that is not on this parabola. I'm going to go ahead and do that. And then this was my inequality. Remember, when you test your point, you're testing it in the inequality, not the equation. So I'm going to put 0 for y and 0 for x. And I want to know if that's true. So this is -4 squared, that's 16 plus 2. So is 0 bigger than or 18? Bigger than or equal to 18? No. So what that means is when I shade, I do not want to shade on the side with the 0. So for this purple graph, I don't want to shade where the 0 is. So nothing on the outside. I want to be on the inside of this parabola. So go. Remember, your solution is where the graphs overlap, right? So the shading where it overlaps. So it's kind of this like little V shape in the middle. So where I have that in gray, that's my solution where they overlapped. Okay, so now moving on, it asks us to write a possible equation for each of the graphs shown. So they might not be 100% accurate. We might be able to get pretty close, like on the line or on the circle, but we're not going to know for sure for the rest of them. So this one, though, I know is exponential, and it's exponential decay. And things that are exponential have the form a times b to the x, and a is our starting value, and b is our multiplier. And we know if it's exponential decay that b value has to fall between 0 and 1. I do know my y-intercept, or my starting value, is 3. And that's really the only point I know for sure. I just know that this has to be a number between 0 and 1, right? So this is where I'm saying it might not be perfectly accurate. Maybe you want to say it's 1/2, or maybe you want to pick 1/3. This just has to be something between 0 and 1. We don't know. I don't have enough information to know what that is exactly. All right, now this is a parabola, and we have a couple of different forms we've talked about for a parabola. We've talked about having an intercept form, right? So if I know where it hits the x-axis, then I could write the factors. We've talked about a graphing or a vertex form, and I do know both. The vertex, I can kind of, I can't really tell exactly where that is. Maybe it's at -6, but I really can tell where my intercepts are. So I have intercepts at 2 and at -3. So if I have an x-intercept at -3, and the factor must have been x plus 3. And if I have an x-intercept at 2, the factor that would have told me that is x minus 2. And since I can't exactly tell like where it's hitting here, I'm going to just like kind of put that a value there to say, yeah, I know there might be some sort of multiplier. I just don't know what it is right now. So it says a possible equation. It does not have to be perfectly accurate if I don't have enough information. Now, B, I do have enough information because that's a line, and I know 2 of the points on the line. So I know I have -3, -7 is on that line, and the point 3, -3 is on that line. So for this one, I could find the slope. So from here to here, the change in y, this is going up 4. And here, the change in x, this is going up 6. So this is the change in y over the change in x. So I know my slope is the change in y over the change in x. So that's 4/6, or 2/3. And then to find my y-intercept, you could do it a couple different ways. I know it's when x is 0, that's my y-intercept. So you could kind of play around with your numbers a little bit, and it's, this is a distance of 3, a distance of 3. You might be like, okay, well, this has to be 2, and you could say, all right, that's -5. You could figure it out that way. You could also write a little equation, right, using y equals mx plus b. I could pick one of these points for my x and my y. So I could put -7 for y. I know my slope is 2/3. I know my x is -3, and I could solve to get b. So when I multiply this, it would be -6/3. So that's -2 plus b. And then when I add 2, I get b is -5. So my equation is y equals mx plus b. So y equals 2/3 x minus 5. Okay, but you could also work that table to figure it out. Right, this is a circle. Circles have this general form for the equation. Remember, HK is your center. And in this case, my center is at 1, 4. Okay, so I know I have x minus 1, that whole thing squared, plus y minus 4, that whole thing squared. And then my radius. So like from here to here, if I count, it's 1, 2, 3, 4. So 4 squared, which is 16. Okay, so there's my equation for that one. So those couple we could get accurately. All right, factoring. Okay, so box and diamond. Remember when we factor, we're always kind of looking for 3 things. First, we're looking, is there a greatest common factor? Sometimes we have one, sometimes we don't. If we have 2 terms after we do that, then we're going to look for, do we have difference of squares? Do I have a squared minus b squared? Because I know that shortcut is a plus b, a minus b. And then if I have 3 terms, that's when I'm going for the box and the diamond. So that's kind of what we want to think about when we're factoring. So when I look at this first one, there is no common factor. It's not 2 terms. It's not difference of squares. So I'm going for the box and the diamond. That's 3x squared. That's 10. Okay, when I make the diamond, this diagonal has to multiply to be the same as this diagonal. So this diagonal is 30x squared. So I need 2 things that multiply to be 30x squared and add to be my middle of 11x. Okay, so I'm thinking 6x and 5x. That multiplies to be 30x squared, adds to be 11x. So I'm going to put those on my diagonal. It doesn't matter. I could have the 5x here and the 6x here. And then what I do is I look at this row and I see, okay, what's the common factor between these? So a 3, and they both have an x. And then from there, I can puzzle it out. So 3x times what is 3x squared? I need an x. 3x times what is 6x? That's a 2, so plus 2. X times what is 5x? That's a 5. And if I've done it correctly, 2 times 5 is 10. So my factors are x plus 2 times 3x plus 5, or they could be flip-flopped. This does just say to factor, so notice I'm not figuring out what x values make this equal 0. It's just factoring. Okay, so if I look at this next one, I notice, right, there is a common factor. They all have an x as part of them. So I'm going to basically undistribute an x from each term. So I'm going to think x times what would get me back to 6x to the third. This would need to be 6x squared. X times what is 31x to the second? I need a 31x. And x times what would be 5x? That's plus 5. All right, now on this piece here, I need to make a box and a diamond. When I write my final answer down here, I do need to include that x that I pulled out as the greatest common factor. So I'm going to just do that now so I don't forget. So in my box, all right, the squared term and the constant number go diagonal from each other. This is going to be negative 90x squared, and this is going to be negative 31x. So now I'm going to think, first of all, I'm going to think, this says 5 and not 15. How many of you are screaming at your computers right now saying, you can't read your own writing, Miss Sandbit? This is a plus 5, not a 15. So how about we go ahead and fix that? I was just sitting here looking at it, thinking, wow, what multiplies to be negative 90 and adds to be negative 31? And I was sort of in the struggle over here. So everybody makes mistakes. So this is going to be 30x squared and add to be negative 31x. All right, so my factors are going to be negative 30x and negative 1x, right? Negative 30 times negative 1 is 30. Negative 30 plus negative 1 is negative 31. So here I have negative 30x and I have negative 1x. And then from this row, what do they have in common as a factor? 6x, and 6x times what is 6x squared? Just an x. 6x times what is negative 30x? That's minus 5. X times what is negative 1? That's negative 1. And if I did it correctly, negative 5 times negative 1 is 5. So then my factors are, I've got this x I pulled out before, it's x minus 5, and 6x minus 1. All right, let's see here, moving on. Again, looking for a greatest common factor. I notice in this case, between the 6, the 15, and the 21, there's a common factor of 3. They all also have an a as part of them. So I'm going to pull that out first. And then 3a times what would get me to a 6ab to the second. So I need a 2 and a b to the second. 3a times what is 15ab? I would need a 5b. And then 3a times what would get me to the negative 21? I need a minus 7. So in my final answer, I have to have that 3a in front. And then I'm going to make a box and a diamond on this again. So I put my 2b squared. Let's make sure I can read my writing here. And my negative 7 there. And I make my diamond. This has to multiply to be the same as this. So that's negative 14b squared. And it has to add to be my middle, a 5b. So this is 7b, negative 2b. Here I have 7b and negative 2b. Okay, from this row, only thing they have in common is a b. So b times what is 2b to the second? That would be 2b. b times what is 7b? That would be a positive 7. 2b times what is a negative 2b? That'd be a negative 1. And then 7 times negative 1 is negative 7. So here I'd have 2b plus 7 and b minus 1. And then for this last one, looking, no common factor. Going right for the box and the diamond. So I have y squared, negative 24. This multiplies to be negative 24y squared. It has to add to be 5y. So what would multiply to be negative 24 and add to be positive 5? So it would be negative 3y and a positive 8y. Let me throw these on this diagonal. And then from these, what's in common is a y. So y times y is y squared. Y times 8 is a positive 8. Y times what is negative 5, and then 8 times negative 5 is negative 24. So my factors are y plus 8 and y minus 5. All right, so then we have some solving absolute value equations and inequalities. So this is back from last chapter. It does say that you need to solve these algebraically, so not guessing and checking, solving algebraically. And the way we did this was we started just by solving for the boundary points as though it was an equation. So absolute value, right? I want to know what would make this inside the absolute value bars equal 7. Or if this were equal to -7, right, the absolute value of -7 is also 7. So I take what's inside the absolute value bar, set them equal to 7 and -7, and then I'm going to solve each of them. So I'm going to subtract 3. So I have 2x equals 4 here, and I have 2x equals -10 here. And then I divide by 2, and I get x is 2, and x equals -5. All right, those are my boundary points. This has the equal to bar, so that means they're going to be solid. And I think if I make this -5, 4, 3, 2, 1, 0, if I make that 0, and then this is 2, then I can get these to fit on my number line. Okay, and then remember what I would do to know where to shade is I would test a point. So if 0 isn't a boundary point, I'm going to plug 0 into my inequality and see if it's true or false. And if it's true, I'm going to shade where the 0 is. I'm going to shade between. If it's false, I'm going to shade out. So I want to know if that's true. So this would be 0 plus 3. That's the absolute value of 3, which is 3. Is that less than or equal to 7? Yes. So that means that my solution falls between. And remember, you're not done until you've also written the solution as an inequality or interval notation. So it's between. So I could either write -5 is less than or equal to x, which is less than or equal to 2, or I could do left endpoint, comma right endpoint. And because I'm including the endpoints, brackets on both. You can write it either way. All right, so here we have an inequality that's quadratic. So I'm going to start by just solving the equation. It's quadratic. You could use the quadratic formula, or you could factor. You can make a box and a diamond. So when I set each of these equal to 0, x equals 3, and x equals -1. All right, those are my boundary points. This does not have the equal to, so those are open circles here and here. And then I'm going to test, 0 is not one of my solutions, so I'm going to test 0 in my inequality. So 0 squared minus 2 times 0 minus 3, and I want to know if that's greater than 0. So that's 0 minus 0 minus 3. Is -3 greater than 0? No. Okay, so I'm not going to shade where the 0 is. I'm going to shade out. And when I shade out, I also have to write the inequality. So I could write here x is less than -1, or for this one, x is greater than 3. That would be inequality. Or if I want to use the interval, my left endpoint here would be -infinity, comma -1, parentheses, because it's an open circle. And then here, parentheses, open circle, 3, comma infinity. So now here we have equations. And for this one, I see this fraction, I've got an x here. I don't like the divided by x. So remember, our trick is to multiply through by the thing that's giving us a hard time, which is the x. I'm going to multiply everything by x. So x times x is x squared, plus x times 3 is 3x, equals 40 over x times x, and I'm going to put that over 1. The x's cancel. It leaves me with just 40. That's the whole point of multiplying through by the x, is to get rid of it. Okay? Again, this is quadratic. But to solve a quadratic, I have to have equals 0. So I'm going to get everything over to one side. And then you can use the quadratic formula, or you can factor with a box and a diamond. This factors into x plus 8 times x minus 5 equals 0. And then I want to know what values of x would make each of these 0. So -8 and 5. All right. So then this one, again, we're solving. I see the square root. I'm going to undo the square root by squaring both sides. So I have 3x plus 13 equals. Now over here, I need to square this. Remember, you can't just square the x and square the 5 as much as you want to, as much as we wish that were true. We have to make a box. That means x plus 5 times x plus 5. So that gives us x squared plus 10x plus 25. It's quadratic again. So that means we have to have equals 0, So I have 0 equals x squared plus 7x plus 12. Again, quadratic formula, or factor with a box and a dime. So it factors into x plus 3 times x plus 4. What would make each of these 0? -3 and -4. Now, for these, we do remember with their square root involved, we need to go back and make sure we don't end up with any extraneous solutions. So we really should be plugging in and double checking these. So let's do that. So if I do 3 times -3 plus 13, does that equal -3 plus 5? So we should check that. So that's -9 plus 13. So that's the square root of 4, which is 2. And then here, -3 plus 5 is 2. So that one works. Okay, and then let's do the same thing here. I do 3 times -4 plus 13. Does that equal -4 plus 5? So that's -12 plus 13. That's 1, and that's 1. And this works. The square root of 1 equals 1. Sometimes we have gotten extraneous solutions when there's a square root, so you can always check your answers. That's never gonna, that's never gonna be a bad idea. All right, composition of functions and then logarithms, and then we're done. All right, so composition of functions, the idea is that you plug a number into one function, and then once you get your answer, you plug that into the other function. So here, when I see this, I would read this as g of f of 14. We start on the inside and we figure out what f of 14 is. It means we're going to plug 14 into rule f in place of the x. So we're going to do the square root of 14 plus 2 minus 5. So that's the square root of 16. So that's 4 minus 1. That equals -1. Okay, so f of 14 is -1. Now I need to take that answer, right? So in place of this, I'm putting -1. And now I have to figure out what g of -1 is. So now I'm going to put -1 in here for x. So 3 times -1 squared plus 5 times -1 minus 1. We're going to be careful with our order of operations because order of operations says power before you multiply. So this is 3 times -1 times -1 is +1. And then this would be -5 minus 1. Careful here, because if you put this into your calculator, you get 1. But if you put this into your calculator, because you put that in parentheses, it's going to give you -1. Right? But I want this quantity squared. I want it to be -1 times -1. I need to put it in this way. If you put it in this way, your calculator thinks you want the opposite of 1 times 1, and that's why it's giving you this. Okay? You don't want to do that. You want those parentheses. So you have 3 minus 5 minus 1. So that's -2 minus 1. That gives me -3. All right, this one, f of g of 1. Okay, so now I'm going to start by figuring out g of 1. So I'm going to put 1 into my g rule. Okay, again, I'm going to square first. So 3 times 1 plus 5 minus 1. So that's 3 times 1, that's 3 plus 5 minus 1. So that's 8 minus 1, that's 7. Okay. So now I figured out that this is 7. I need to figure out what f of 7 is. So that means I'm going to put this 7 up here for x. So I'm going to have the square root 7 plus 2 minus 5. That's the square root of 9 minus 5. So that's 3 minus 5. That gives me -2. Really didn't beat myself up. All right, and then the last one, g of f of -1. So I'm going to start with that f of -1. So the square root of -1 plus 2 and then minus 5. So that's the square root of 1 minus 5. That's 1 minus 5. So f of -1 is -4. And then I want g of that. So g of -4. So I have 3 times -4 squared. Let me put in the -4 in here and here. Plus 5 times -4 minus 1. Again, order of operations, I'm going to square the -4, which is 16. And then that would be -20 minus 1. So that's 48 minus 20. So that's 28 minus 1, which is 27. All right. And then finally, logarithms. So the big thing when we had logarithms was we thought about rewriting things in exponential form. So exponential form is when you have that b to the x equals y, and then logarithmic form is log base b of y equals x. So these are in this logarithmic form. It helps to rethink of it in this exponential form. So to think of it as, okay, my base is 3 to what's in the spot of the x, my question mark, 3 to what power is 243. And then you want to look on your power sheet and see, okay, 3 to what power is 243, which is 5. Okay, and our answer is 5. The answer is not to write 3 to the 5th equals 243. The answer is 5. Okay, so I'm going to keep going here. So here I would have 5, right? That's in the spot of the B. 2 to the 3rd power is what I'm looking for. And I'm going to look on my power sheet. 5 to the 3rd is 125. Okay, here I have 8, right? To what power is 8 to the 5th? And if these are equivalent, then it would just be 5. Okay? And you might remember that if these little bases are the same, then the answer ends up just being that power. Okay? But if you don't remember that, then you can always go to that exponential form. All right, here I would have 2 to what power equals 1. Okay, 2 to what power? Anything to the 0 power I know is 1, so that would be 0. All right, and then this one, I have 6 to what power is 1 over 216. Okay, now I know 6 to the 3rd is 216, but the 216 is in the bottom. And then the rule that puts things from the top and the bottom, right? If you remember our exponent rules, if I have a negative exponent, it makes it move to the bottom, and then a positive exponent. So I would need this to be a negative 3rd to make it equal 1 over 216. So my answer here would be negative 3. All right, here I would say 7 to what power is the square root of 7, right? And so square root of 7, I want to rethink of that as a power. So we learned that if I have the nth root of something, that's the same as that base to the 1 over n power. And if it's a square root, it's as though that's a 2. So I'm thinking 7 to what power equals 7 to the 1/2 power. So then this answer would have to be 1/2. All right, this one's asking what to the 9th power is 4 to the 9th. Again, like since this is a 9 and this is a 9, that means these bases have to be the same. This must be 4. So you might have realized that here just looking at it, or you could always rewrite it. All right, and then this last one, 9 to the negative 3rd power equals what? Okay, so the negative exponent using this rule I know is 1 over 9 to the 3rd. And 9 to the 3rd is 729. So this is 1 over 729. All right, I hope that helped.